All right, guys, we're going to begin Module 4 today. Module 4 is on transformations and symmetry, and we're going to start working on transformations first. Today's transformation is on reflections, and we're going to work on reflecting the figures in the coordinate plane and then describe the effects of these reflections. Okay, so first of all, what is transformations? Well, a transformation is the process in which we change the position and possibly the size and orientation of a shape. And this takes place on the coordinate plane. It doesn't have to be on a coordinate plane strictly, but that's where we're going to work with it primarily. All right, there are four types of transformations. There's reflections, rotations, translations, and dilations. Okay, what we're going to work with primarily right now are called rigid transformations. And a rigid transformation is one in which the image does not change in shape or size. So you are making a duplicate copy of the original shape during a rigid transformation. Okay. Now, reflections, translations, and rotations, these are rigid transformations. When you do a reflection, a translation, or a rotation, you are going to move a shape somewhere in the coordinate plane, and that shape is going to be the exact same size and shape as the original version of it. So that's called rigid because it doesn't change. Okay. The angles in the shape are all going to be the same. The side lengths in the shape are all going to be the same. It's going to be the same shape. Okay. Now today's work is reflections. All right. Or sometimes called flip. Okay. A reflection is when, or excuse me, let me go this way. When a figure is reflected, each point of the pre-image and its corresponding point on the image are going to be the same distance from the line of reflection. Okay. Now let's add a couple things here. Number one, when they say pre-image, what are we talking about? So the pre-image is the original or initial point or set of points that you're going to reflect. So that's what you're given originally is the pre-image. The image is a result of the transformation that's been applied. And in our case, we're going to do reflections today. Okay. And then the line of reflection is the line in the coordinate plane that's being designated as the fixed line for which our reflection is going to be created over, or we're going to reflect it over. Okay, so now going back up and rereading it. So when a figure is reflected, each point in the pre-image, the original, and its corresponding point on the image, our new creation, are the same distance from that line of reflection, which is a line they've designated that we're going to work our reflection over. Okay, so there's all kinds of different ways we can look at reflections and do it in the coordinate plane. And I'm going to go through a lot of these examples with you. So first of all, it's something simple here. Reflect the point across an axis using the pencil. Now this is the pencil on the Alex program. Plot the point of reflection of A across the x-axis. All right, so if I'm going to reflect A across the x-axis, first of all, we have to identify the x-axis correctly. So this red line is the x-axis. Now I'm going to reflect A over this axis. Okay, by definition, a reflection is the same distance from the point, which is the line of symmetry. Okay, or the line of reflection. So if you look at this, if I go from A to the x-axis, I go 1, 2, 3, 4 units. I want to travel away from the x in the opposite direction, 1, 2, 3, 4 units. Okay, I also want you to notice that this line is perpendicular to this line. So when you move to the line and away from the line, it's got to be perpendicular. And as long as we're moving, vertically towards a horizontal line, we're moving perpendicular. Okay, so our final answer here would be the point that you would draw down here. Now, typically, when we do reflections, we relabel the points as A prime or whatever this letter is prime. Now, you don't have to do that in your homework tonight. You just got to mark this point, but I would call this A prime. There's our answer right there. Okay, so reflections, again, you work to the line of reflection and then work the same distance away from it in the same line. Okay. So the point A is shown below. We're going to reflect A across the x-axis, and then we're going to reflect the result of that first one across the y-axis. And they only want your final point in your answer. All right, so the first thing I would do is take point A, and we're going to reflect it over the x-axis. So again, here's the x-axis. Okay, so point A is 1, 2, 3, 4 units to the x-axis. So I go 1, 2, 3, 4 units in the other direction. And there's my first point. Okay, that's called my first image. Okay, now we're going to take this point and we're going to reflect it over the y-axis. Okay, so now this point is 1, 2, 3, 4, 5, 6 units from the y-axis. In the same line, I'm going to go 1, 2, 3, 4, 5, 6 units, and there is going to be my answer. Just this point. You're going to erase this one, not keep that one. You just want this point as your answer. So we reflected it over the x and then over the y. And again, you count to it and count the same distance away in that same line. Okay. The figure below has a marked point with a large dot. Right here's what we're looking at. First, reflect the figure across the y-axis, then give the coordinates of the marked point in the figure and the final figure. Okay, if we're ever asked to reflect this entire shape over the, in this case, the y-axis, okay, what we need to understand is you don't have to do every little point along here. What you do are the 4 vertices in this case. Okay, so what I would do is I'd start with each vertice. And so let's say I started this vertex. I'm going to go 1, 2, 3 to the y-axis. 1, 2, 3, put a point. This point, 1, 2, 3, 4, 5, 6. So now I'll go 1, 2, 3, 4, 5, 6, put a point. This one, 1, 2, 3, 1, 2, 3. And notice I'm doing it in the same line that I count in. This one is 6 units over, count 6 units over. And if you do that and put the points where they belong and redraw it, here's your image. Again, this is the pre-image. This is the image. Okay. Now the question was, when I do this reflection, what does this point become? Well, originally the point was at 6, 3, and now the point is at -6, 3. So when I reflected over the y-axis, this point that they were featuring here becomes this point, and it's at 6, -3. Okay. Give the coordinates of the points obtained from each reflection. So the first one says take the point 4, -3 and reflect it across the x-axis. Okay. So here's the point 4, -3 down here, right? Over 4, down 3, and reflect it over the x-axis. So I'm going to count to the x-axis, 1, 2, 3. I'm going to count 3 away from the x-axis in the same line, 1, 2, 3. There's my new point. That ordered pair is at 4, 3. So when I reflect 4, -3 across the x-axis, I get 4, 3. All right, now we're going to take 4, -3 and reflect it on the y-axis. Okay, so again, here's my pre-image, 4, -3. Now we're going to reflect it over the y-axis. So count to the y-axis, 1, 2, 3, 4. Count away from it, 1, 2, 3, 4. Okay, and here is my new image. So when I reflect 4, -3 over the y-axis, the point is located at -4, -3. That's its new location. Okay. Okay, reflect the ordered pair 4, 5 across the y-axis, then reflect the result across the x-axis. What's the coordinate of the final point? So they're going to give you a grid to work with. So take your grid, plot 4, 5, reflect it over the y-axis. That's the vertical one. So I count 1, 2, 3, 4, 1, 2, 3, 4. There's my first image. Now I got to take this image and reflect it over the x-axis. So now I got to count to the x-axis, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And here is my second image. Okay, they wanted the coordinates of the final point. So they want this set of coordinates. So I would tell them the answer is -4, -5. Start with this pre-image, reflect it over the y, then reflect that one over the x, and I'm here at -4, -5. Okay, properties of reflected figures. So it says reflect this figure over the y-axis, then decide if each statement about the reflected figure is true. So if I'm going to reflect this over the y-axis, again, remember, we're going to go to the 4 vertices and we're just going to reflect them. So if I start at this corner, this point, it's 1, 2, 3, 4. So go 1, 2, 3, 4, put a point. Same line, it's 6. I'm going to go 6, put a point. This corner, 4, go 4, put a point. This corner is 7, and then then go 7 this direction, put a point. And if you do that, Here's my line of reflection. This is the image. Here's the pre-image. That's what they gave us. Here's the image. Okay, it's been reflected over the y-axis or flipped if you think about flipping it over that. Okay, now one thing to point out before we start this, these are rigid transformations. So every side length in my image is exactly the same as the original. Okay, every angle's the same, every side length's the same. This image is a duplicate copy of this one. They're identical. So read the statements here. The final side lengths are the same as the original side length. True. The final angle measures are the same as the original angle measures. Excuse me. True. If two sides are parallel in the original figure, then the two sides are parallel in the final figure. Remember, they're identical. So if they're parallel in the first, they're going to be parallel in the second. The original figure and the final figure may not be congruent. False. They are congruent. They're exactly the same image. Okay. Okay, next idea here, determine if the figures are related by a reflection. In each part, reflect the solid figure exactly onto the dash figure. If not possible, click not possible. Okay, so if we started with the solid in A here and reflected it over a line to get to this one, is this what the image would look like? Well, let's take this point. 1, 2, 3, 1, 2, 3. Yeah, that point matches this point. 1, 2, 3, 4. 1, 2, 3, 4. That point should be up here. Okay. So what happens in this case, if I do it, is if I was to map the original, take the original and reflect it up here into this quadrant where this one is located, it would not match. Okay. This dashed image is not the reflection of this. So it's not possible for that one to happen. How about in B? Well, again, if you start with a corner, and this looks like it's reflected over the y-axis this time. So let's count from this corner to the y-axis. That's 5. From the y-axis to this point, 5. From this back corner to the axis is 6. From the axis to that back corner is 6. And it's all in the same line, right? So from this point to the x-axis to y-axis, I'm sorry if I've been saying axis, y-axis is 5, 5. From this point, it is 6, 6. That's an exact mapping. Okay, it's an exact reflection. So this image, this pre-image, is this image when reflected over the y-axis. So that one, yes, it is the exact same. They are related by a reflection, and that reflection would be over the y-axis. Okay. Draw the reflection of the following triangle over the line P. Okay, so now it doesn't always have to be reflected over an axis. It can be reflected over any line they want to give us. The idea here is, so here's this line P, which is actually the line y equals -2. Remember, a horizontal line is y equals a negative number right here. All we're going to do is take the 3 points of the triangle, and we're going to count from the point to the line of reflection, from the line of reflection in the opposite direction. If we do that, then the A, well, let's call this point A. They labeled as A. Go 1, 2, 3, 4 to the line of reflection. 1, 2, 3, 4. A prime is right there. B is 1 away, so go 1 the other direction. There's B prime. C, count 2 it. Count 2 away. There's C prime. And if you graph it, remove these little lines I've drawn in there, there's the reflection. So this is my pre-image. This is my image. This triangle reflected over this line is this image right here. Okay. In the coordinate plane, the points A, B, and C are reflected over the y-axis to the points A prime, B prime, C prime, respectively. What are the coordinates of A prime, B prime, C prime? So to do a problem like this, guys, I need a grid. So I'm going to make a grid. All right. And I'm going to plot the points A, B, and C. So here's A. It's at 5, -3. Here's B at 6, 2. And then C is over here at 10, -10, 11. Now, if we reflect these over the y-axis, they want to know what the new locations are. So C is 10 units from the y-axis. So go, perpendicular. Now count 10 units to it, 10 units away. C prime would be located here, which is at 10, 11. B starts at 6, 2. So now I'm going to count to the y-axis away from it. B prime would be at -6, 2. A starts here at 5, -3. So count 5 units to 5 units away. We'd be at -5, -3 for A prime. So you got to make a grid and look at it, and you're counting to the line of reflection and away from it to get your locations. Okay, the last one here. All right, it says that we're going to reflect FGH, which is this top one here, across the horizontal line y equals -2. That's this line. We get this image, H prime, G prime, F prime, G prime, H prime. Suppose that F to F prime, F to F prime, G to G prime, this dash line, and H to H prime intersect the line of reflection at their respective points, P, Q, and R. Answer the questions here. Well, remember, guys, this is a rigid transformation, okay? And we always move perpendicular to the line of reflection and away in the same line. So the first question says, suppose each pair of lengths below have the same length. Find each length. All right, so they're asking us to find the length of the point to the line of reflection and then the line of reflection to the other point, to the image. So what you got to do is count this up, right? Well, I'm not counting it up. I'll just show you. F to P is 6. That's F to the line of reflection. Line of reflection to F prime is 6. G to line of reflection is 3. Q to G prime is 3. H to R is 5. R to H prime is 5. So we know we always count the same distance to the same distance away. So we can put those answers in here. Okay. Here, select all that apply. F to F prime, G to G prime, H to H prime are each parallel to the line of reflection. So are these dashed lines all parallel to this line of reflection? No, they are not. Are those lines perpendicular to the line of reflection? Yes, they are. F to F prime, is it perpendicular to G prime? So here's F to F prime. Is that perpendicular to G prime? No, it's parallel, so that's not correct. None of the above, that's not correct because we got one. So there's our answer. Okay, down part C, choose all the statements that's correct here. The first statement, the line of reflection, which is this line y equals -2, is perpendicular to the bisector of each segment, is the perpendicular bisector of each segment joining a point in its image. So is this line y equals -2 the perpendicular bisector of this segment? Yeah, it cuts it in half, right? Because we count to it and away from it's the same distance. So point P represents the midpoint of F to F prime. Q represents the midpoint, G to G prime. R represents the midpoint, H to H prime. That's true. All right. Now, because these are circles here, it's not choose all that apply. This is usually choose the one that's right. So that should be the only one that's correct. If you read the rest of them, the line of reflection is neither parallel nor perpendicular to each segment joining the point to its image. Well, it's perpendicular. The line of reflection is perpendicular to each side of the original figure and the final figures. No, this line of reflection is not perpendicular to these lines, which make up the image. And the line of reflection is parallel to each segment joining the point in its image. No, it's perpendicular. So that's that. Okay. All right. So you're going to see all these types of questions tonight on your homework. All right. A lot of examples that I went through with you. They get a little redundant, but now you've seen them all, and I will let you get at your homework.